Suppose a plus b plus c equals to pi over 2 radians. We need to show the following. Okay, let us begin. So what we'll do, we'll start our proof from the left hand side. On the left hand side, we have sine squared a added to sine squared b added to sine squared c. So here what we'll do, we're going to change the first term sine squared a to cosine squared a. Now that's an easy task. All we have to do is use the identity that sine squared theta plus cosine squared theta equals to 1. So we can use this to rewrite sine squared a as 1 minus cosine squared a. Added to, we have sine squared b plus sine squared c. Okay, so now what we'll do, we're going to keep the first term 1 as it is. We're going to combine the second and the third term by taking negative as the common factor, such that we have cosine squared a minus sine squared b added to sine squared c. Okay, the reason why we converted sine squared to its equivalent cosine squared function, because now what we have here is a standard formula. So cosine squared a minus sine squared b, let's note it down, cosine squared a minus sine squared b. This can be factorized to get cosine of a plus b multiplied to cosine of a minus b. So that means we now have 1 minus cosine of a plus b multiplied to cosine of a minus b plus sine squared c. Okay, so here what we'll do now, we're going to next transform cosine of a plus b to its equivalent form. So here let's take the help of the given condition, that is a plus b plus c equals to pi over 2. So since we have a plus b plus c equals to pi over 2, we can transpose c to the right hand side to get pi over 2 minus c. Next, we are going to take the cosine function on both sides to get cosine of a plus b equals to cosine of pi over 2 minus c. Now, what is cosine of pi over 2 minus c? This is simply equals to sine of angle c. Now, that means cosine of a plus b, this is the same as sine of angle c, provided a plus b plus c equals to pi over 2. So now what we get is 1 minus sine of angle c multiplied to cosine of the angle a minus b added to sine squared c. So what we'll do, we're going to take negative sine c as the common factor from the second and the third term. So that means in the second term we are left with cosine of a minus b minus, since we have taken sine c as the common factor, so from sine squared c we're left with sine c. Okay, fine. So what we get is 1 minus sine of angle c multiplied to cosine of angle a minus b. Now what we'll do, again we are going to change sine c back to the cosine function such that we get cosine of a plus b. Now we have done this because what we get here is the difference of two cosine function and we can easily combine them. So using the fact that whenever we have cosine of c minus cosine of d, so this is given by 2 times sine of the angle d plus c over 2 multiplied to sine of the angle d minus c over 2. Okay, fine. So here we will assume a minus b to be c and a plus b to be d. So we get 1 minus sine c multiplied to 2 times sine of the angle. So d plus c over 2, that's going to give us a, and d minus c, that's going to give us b. So we get sine b. So let's rearrange the terms. We get now 1 minus 2 times the product of sine a times sine b times sine c, and this is exactly the expression on the right hand side. So we can confirm that the 1 minus 2 times sine a sine b sine c. So thus we have successfully verified that the left hand side equals to the right hand side, hence proved.